All right, so we are going to be looking at Unit 6, and this is where a lot of our new content is going to come out here, the stuff that we did not get to last year. Now, the first thing you need to be aware of is that you probably know this first section. I think we at least did the area between two curves last year, but I'm going to go into detail whether we did or not. All right, so in Unit 6, this is Unit 6 from last year. It is not Unit 6 from this year. This is Chapter 6 from your old textbook from last year. It's the area of the region between two curves, 6-1. I will write and evaluate an integral to find the area between two curves. So we're going to be using integrals, and we're going to be finding area between two curves. So far this year, last year, all you did was you found the area from the curve down to the x-axis. But technically, you actually did the area between two curves. You actually did the area between the curve and the x-axis. So we really have been doing the area between two curves all along, really. All right, so here's what we're specifically going to be doing. We're going to be given two curves. So this will be like curve number 1, and then this would be curve number 2, or vice versa. All right, so we got two curves here. We want the green area between them on the interval from A to B where they intersect. Okay, so how are we going to find the area between them? Well, like I've said before, we have already been doing all year long, we have found the area under a curve down to the x-axis. All right, so we've been doing that last year. All right, we already know how to do that. Okay, so what we're going to do is we're going to calculate the area under both of these curves down to the x-axis. Okay, so this blue picture is the area under the top curve down to the x-axis on the interval from A to B. This pink picture is the area under the second curve, or vice versa. I numbered them 1, 2, 3. So this is this one's number 2, and this is number 1. All right, so this is the area under this curve down to the x-axis. So how can I find the green area? Well, if I take the blue area and I subtract away this part that's pink, I'll be left with the green, right? So if I start and calculate all of this area, then I calculate this pink area and subtract these two answers, then I'm going to get the area left that's above this curve here. I'm going to get that area that's between the two curves. That's the green part. So the idea is you have to find the area under the top curve, find the area under the bottom curve, and then all you're going to do is subtract those answers. That's all you're going to do. All right, so here's what it looks like. If we have two continuous functions, f and g, on an interval from A to B, and we know that G is the curve that's underneath F. So G is the bottom curve, right? So that's what that means. G is underneath the curve, is less than the curve of F. So that means G is the one underneath, and F of X is the one on the top. Okay, and we want to find the area between them. All right, so G of X is down here. All right, so F of X is the top curve, G of X is the bottom curve. All right, then the area of the region bounded by the graphs of F and G, so the area of the region bounded between the two of them, and the vertical lines x equals A and x equals B. So that would be at their intersection points, which would be at x equals A and x equals B. So that would be A on the x-axis, this would be B on the x-axis. All right, is going to be this integral. So the area between these two curves is the integral from A to B of f of x, the top curve, minus g of x, the bottom curve. So it's got to be top minus the bottom. If you do bottom minus top, then you're going to end up with negative answers, right? Because you're going to be doing the smaller piece minus the bigger piece. So you got to do the top curve minus the bottom curve, or else all your answers are going to be negative when they shouldn't be. Okay? So that's how you find the area between two curves. You just do the integral of the top curve minus the bottom curve. All right, so what happens if one of your curves is above the x-axis and the other one is below the x-axis? Does this still work? does the integral from a to b of the top curve minus the bottom curve, does that still give us the correct answer? Well, if you think about this, the area from under f of x down to the x-axis would be this part. Then the area of g of x to the x-axis is going to be this part. And if you remember, anytime you have area below the x-axis, that area is going to be negative, right? Well, in that case, you're going to be doing area minus a negative expression, a negative answer. So you're going to end up adding. So you're ending up finding this total area because you're going to end up adding the area that is below the x-axis, because you're going to minus the area of g of x, which is going to end up being a negative number because it's below the x-axis. So you're minusing a negative. So you end up adding, and so you end up getting the total area. So yes, it does work when one of your functions is above the x-axis and the other one's below the x-axis. This still works. All right, so what if both of your functions are below the x-axis? Does it still work? Okay. All right, so let's check that out and see. So you're going to do top function, which is this function here. F of x is the one on top. So I'm going to find his area first to the x-axis. Well, his area to the x-axis is going to be negative. So this is going to be a negative area. Okay. Then I'm going to find minus. Then I'm going to find the area of g of x. Well, g of x is this curve. And his area to the x-axis is also going to be a negative number minus a negative area. And so you're going to end up adding the area of the larger one, right? So you're going to be doing the larger area minus the smaller area, and you're going to end up with the orange part. So it still works, all right? Because you're going to end up the negative small area minus the negative big area, which means you're going to be adding, all right, the bigger area to the negative small area, and it leaves you with this orange piece, right? So it works both ways. So the way to find the area between two curves is always to do top curve minus bottom curve every single time. It's always going to be the integral from a to b of top curve minus the bottom curve every single time. And you're going to integrate that, and that'll give you the area between the two curves. Now, notice here they didn't intersect at A and B. We just found the area between them on the interval from A to B. So sometimes they may intersect at that point, or sometimes we may just be finding the area between the two curves on a specific interval. All right, so it may not be their intersection, but that's all it is, the integral from A to B of the top curve minus the bottom curve. All right, so that's your content video. So next you should watch your example video.